Well, this video is going to give you the information of finding the perimeters of a cubic function. Function is generally in form of f at x is equal to ax cubed plus bx squared plus cx plus d, where a can never be equal to 0. B can be equal to 0, C can be equal to 0, and D can be equal to 0. Now, let's take a look at the question. When one point of the graph is given and the turning point is also given. If the graph of f is defined as negative x cubed plus ax squared plus bx plus c, which is 12, and the graph passes through the point negative 3 is to 0, and it has the turning point of 2 is to 0. Then how do you determine the values of a and b? So which are the perimeters that are found in the graph f at x? So the idea is to know the nature of these points. This is just the general point that is found in the graph f at x. But this turning point, this point is regarded as a special point that is found in that graph. Generally, we know at the turning point, the gradient of a cubic function or the gradient of any function is equal to 0. So the idea of using this turning point is where we are going to use turning point theorem. Let's write down our function. F at x is equal to negative x cubed plus ax squared plus bx minus 12. We can just substitute by this general point to the values of x and the values of y to find the first equation. It's always the case that when you have 2 points, when you have 2 unknown, you are going to have 2 equations and solve them simultaneously or any method of your choice. So the idea is to take this point and substitute in the place of x and in the place of y, just like that. In the place of y, we put 0 because our point is negative 3 is to 0. In the place of x, we put the x coordinate, which is negative 3. So we eventually get the equation 1, which is defined as 0 is equal to 15 plus 9a minus 3b. So how do we then obtain the equation number 2? Equation number 2, we are going to use the coordinates of the turning point. But understanding the idea of turning point theorem, that we have to find the derivative at the turning point and equate the derivative to 0 and find the second equation. So this takes us to finding the derivative of f at x, which is defined as f prime of x is equal to negative 3x squared plus 2xa plus b. So we are in a point of substituting by what now? By this point, which is 2. And in the place of f prime, we're going to put 0. As you can see, at the turning point of any graph, the gradient is equal to 0. Now, this is our what? This is our second equation. After finding the second equation, we can use our simultaneous equation, our simultaneous method, or we can eliminate. But in this case, I prefer the simultaneous method, whereby we can just make one of these unknown to be one of the subject of the formula. So B is now defined as 12 minus 4a from equation number 2. So after that, we have to substitute to equation number 1. Where there is b, we are going to put this this formula, which is what? Which is 12 minus 4a. So basically, we have now 15 minus plus 9a minus 3b. Then in the place of b, we put 12 minus 4a. The idea is to solve the value of a. Hence, we have now simplified the value of a to be just equal to 1. After finding the first perimeter, it's easy to substitute to our one of the equations. So when we substitute to this equation, we get b, which is equal to 8. So we can now write our function as y is equal to negative x cubed plus x squared plus 8x, then minus 12. So this is basically how do you find the perimeter when one point is given and the turning point is given.